Hi, my name is Dhruti and I am currently a junior and I worked from home in Dr. Alex Bertuccio's lab on emulsions over the summer. So what is an emulsion? An emulsion is a homogeneous mixture of two immiscible liquids where one is finely dispersed in another. And you can find emulsions in a variety of different industries such as food, cosmetics, and pharmaceuticals. And although they're found in a variety of different areas, they're not commonly studied. So this is my proposal of adding a hands-on lab to the chemical engineering undergraduate curriculum. In order for an emulsion to be formed, you need to add a surfactant, which is an amphiphilic molecule. And so when you add surfactants in an oil and water emulsion, it coats the oil droplets, and the two different stabilizers that it allows is electrostatic repulsion, which is between the charged head molecules, or steric hindrance, which is the physical boundary of the shape of the head. And in order for us to test emulsions, what we did is we took a test tube and added water and oil and then various different types of surfactants and agitated in different methods. And what we did is we calculated the amount of time it took for it to separate to 80% of the water height that it started off with. So one of the things that we tested was the different types of agitation. And we found that as it was more vigorously agitated, it created a more stable emulsion. And this is probably because there is just more surfactants, coating the oil droplets, which allowed for more steric hindrance or electrostatic repulsion. Another thing we tested was the oil and water ratios, and found that as there was a higher ratio of oil to water, it created a more stable emulsion. So as there was more oil, it was a more stable emulsion. And this is probably due to the fact that there are more oil droplets, so in order for them to combine back together, it would just take a longer amount of time. One other thing we tested was the type of surfactant. So we tested tween 80, which is a non-ionic surfactant, and cocabetanine, which is a zwitterionic surfactant, and found that tween 80 created a more stable emulsion. And that's due to the fact that the shape molecule of tween 80 has a much larger head when compared to cocabetanine, so it has a higher steric hindrance. The last thing that we tested was the temperature of the water, and found that as warmer water decreased the emulsion stability. And that's due to the fact that with cold water, there is less kinetic energy, so the molecules are moving around less and having less interactions, so there is a slower rate of coalescence. So in conclusion, we found that agitation style, the ratio of oil and water, the type of surfactant, and the temperature of the emulsion affected emulsion stability. And as you can see, there's a variety of variables that can be tested, and it's available for an open-ended lab experiment that could be added to a senior year chemical engineering curriculum. Also, all the materials used in this lab are very cost efficient, and it could be done at home or in person. In conclusion, I would like to thank Dr. Alex Bertuccio for letting me being part of his lab, and Project Super for allowing me to have this opportunity to present the poster. Thank you.